Okay, we'll have a look at the example in the book that you've got and go through how we would solve it. It tells us at the start of cargo, our vessel's at an even keel, 6 metres in salt water, LBP 140. And then we load 2 parcels and discharge 1, and we need to work out the final drafts forward and aft. Okay, now when a vessel is at an even keel, if we look at the drawing that you've got in the book, when a vessel's at even keel, B and G are in the same line. If you think of your vessel when we did transverse stability, buoyancy and gravity forces are equal and opposite. Well, it's the same longitudinally. If the vessel's at an even keel, the values of LCB and LCG are exactly the same. Now, in this problem, of course, we need our initial LCG of the vessel, because it doesn't tell us that, but it does tell us our draft is 6 metres in salt water. So if we go into the tables at 6 metres, we can get our initial displacement, and we use the LCB as our LCG, because at an even keel draft, LCB and LCG are exactly the same values. So we went in at 6 metres and picked out displacement and LCB, and that is what we use as the LCG because the vessel is at an even keel. Okay, if the vessel wasn't at even keel, you'll either be given your displacement and your LCG, or you would have to calculate the LCG using the formula if you're given your drafts forward and aft. But in this instance, we've simply gone into the tables, we've got our displacement, our LCG. Then we've added 2 parcels of cargo and discharged 1 parcel, and everything is measured from the after perpendicular. So the centre of gravity of this parcel of weight, for example, is 110 metres forward of the after perpendicular. So everything is FOAP, forward of the after perpendicular. And on the tables it's got LCB, LCF, longitudinal centre, longitudinal centre. Again, they are measured, as it says there, forward of the after perpendicular. FOAP, forward of the after perpendicular. So just like when you got your kg of the vessel, we add all the moments together or subtract them if we've discharged, the weight, final LCG is total moments over total weight, and we've got an LCG in this instance of 69.59. Then what we need to do is get the 4 values from the hydrostatic tables. We need the true mean draft, LCF, LCB and MCTC, and we'd need to go in at 14,397 in salt water, and you can see that it doesn't fall exactly on either of those values, so we need to interpolate between them to get the 4 values. I'm not going to go through the interpolation here because there is a video on interpolation, but by interpolation our true mean draft was 6.923, LCF 67.43, LCB 70.07, MCTC 183.4. So we picked those 4 values, and we've also got our LCG of 69.59. What we then do is put them into our formula, which is on your formula sheet, which is trim is displacement times LCB difference LCG over MCTC. Now remember, if B is greater than G, the BGs, B is more than G, you must be trimmed by the stern. So what that means is from your true mean draft, you would add to the after amount to get your trim by the stern, and of course subtract from the forward amount. So we get our total trim by multiplying displacement times LCB difference LCG, divide that by MCTC, because weight times distance are moments. So what all we're doing here, we're working out the total moments that have been created, dividing by the moments required to change the trim by 1 centimetre, and that gives us the amount of centimetres we're trimmed by. So whatever value you get from putting these values into the formula, you will end up with centimetres, okay, because you've divided the moments to change the trim by 1 centimetre. And in this instance we've got 37.7 centimetres by the stern. Now to get the aft effect, it's simply LCF over LBP times the total trim. So we work out that we're trimmed aft by 0.182 of a metre. Of course the forward effect would simply be aft minus the total trim minus the aft amount, which gives us 0.195. Because we're trimmed by the stern, our true mean draft of 6.923, we add 0.182, and our forward draft 6.923, we subtract 0.195, and that gives us our final drafts forward and aft. So be careful that the trim comes out as centimetres. Make sure that if you understand LCB is greater than LCG, you must be trimmed by the stern. And finally, a very common mistake that students make, surprisingly, when they come to apply the trim, some students use the initial draft the vessel was at, 6 metres. Don't do that. Always use the true mean draft that you've got from the tables after you've loaded and discharged all your cargo. So that's the true mean draft value you use to work out your final drafts forward and aft. So in this instance, as soon as you see even keel, you know that LCB and LCG are exactly the same value.